In this episode, we step back from individual controls and look at a bigger question that quietly decides whether a security program feels organized or chaotic. What exactly counts as security architecture, and where does it begin and end? Beginners often imagine architecture as a diagram of networks and servers, but security architecture is really the set of decisions that shape how security outcomes are built into systems, processes, and platforms. Those decisions have a scope, meaning a defined boundary of responsibility, and they also have types, meaning different layers and viewpoints that are used for different purposes. When you can describe scope clearly, you stop trying to solve every security problem at once, and you start focusing on the decisions that architecture is supposed to own. When you can describe types clearly, you stop arguing about whose diagram is right, and you start using the right architectural view for the right question. This matters for the information systems security architecture professional, ISSAP, mindset because many exam scenarios are really asking whether you understand what architecture should cover and what it should leave to design details, operations, or governance. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at DailyCyber.News in the Bare Metal Study Guide series. A strong definition begins with the idea that architecture is about structure and guiding decisions over time, not just about documenting what exists today. Security architecture explains how security requirements are translated into system qualities like controlled access, trustworthy identity, resilient operation, and credible evidence. It also sets patterns that teams can reuse, so security becomes consistent across projects rather than reinvented each time. This consistency is one of the biggest practical benefits of architecture, because without it, every team solves the same problems differently and gaps appear in the seams between systems. Security architecture is also a bridge between governance and engineering, because it connects policy and risk decisions to real design constraints. Beginners sometimes confuse architecture with security operations, but operations is about running and responding daily, while architecture is about shaping the system so daily operations are possible and predictable. When you keep that distinction in mind, scope becomes easier to define because you can separate shaping decisions from day-to-day execution. Scope answers the question of how big the architectural responsibility is for a given effort, and it is best defined by purpose and boundary rather than by organizational chart. Sometimes the scope is a single system, such as a customer portal or an internal analytics platform, where you are deciding what security properties the system must have and how it will achieve them. Sometimes the scope is a shared platform, such as an internal cloud landing zone, where you are defining baseline security services and guardrails that multiple teams will use. Sometimes the scope is enterprise-wide, where you are defining consistent patterns for identity, data classification, logging, and network segmentation across many systems. The scope should also specify what is in scope and what is out of scope, not as a way to avoid work, but as a way to prevent confusion about who owns decisions. If scope is not explicit, teams often assume architecture is responsible for fixing every vulnerability, writing every policy, and managing every incident, which is unrealistic and leads to disappointment. A clear scope protects both security outcomes and team sanity by making responsibilities precise. Enterprise security architecture is often connected to enterprise architecture, EA, which is the discipline of aligning technology structure to business goals across the organization. The enterprise view matters because many security outcomes depend on consistent decisions that cut across systems, such as how identities are managed, how data is classified, how privileged access is controlled, and how evidence is collected. If each system chooses its own approach to these foundational questions, the organization ends up with inconsistent controls and weak visibility, even if each system appears secure on its own. Enterprise scope also helps with prioritization, because it allows architects to focus on high-leverage decisions that improve security everywhere, like baseline configurations, shared monitoring, and common patterns for segmentation. Beginners sometimes think enterprise architecture is too abstract, but the real value is that it reduces friction by creating predictable defaults. It also clarifies where local teams have freedom to innovate, and where they must follow standard patterns for safety and compliance. When you define enterprise scope well, you create a stable foundation on which system-specific security designs can be built more quickly and consistently. System or solution security architecture is a different type of scope, and it focuses on how a specific system meets security objectives within enterprise constraints. In this scope, you are concerned with system boundaries, trust zones, data flows, entry points, and the way components interact. You define where authentication happens, where authorization is enforced, how sensitive data is protected, and what logging and monitoring are required for accountability. You also think about failure behavior, because resilience is part of security, and a system that fails in unsafe ways can become a security incident during an outage. Solution scope is where architectural trade-offs become visible, such as balancing usability with strong access control or balancing performance with deeper inspection and monitoring. This is also where many beginner misunderstandings show up, because it is tempting to focus on one control like encryption and assume the problem is solved. A solution architect must instead consider how controls work together, what assumptions they rely on, and how they will be maintained over time. The scope is narrower than enterprise, but the decisions are still architectural because they shape system behavior, not just implementation details. Another important scope is platform security architecture, which is especially visible in cloud environments where shared services and guardrails strongly influence outcomes. A platform scope defines baseline security capabilities that many systems will inherit, such as identity integration, network segmentation patterns, logging collection, and configuration standards. This is powerful because it reduces the burden on individual teams and increases consistency, but it also increases the responsibility of the platform design, because mistakes can affect many systems at once. Platform scope also requires careful attention to boundaries between platform responsibilities and application responsibilities, because shared responsibility does not mean shared ambiguity. For example, a platform might provide authentication services and logging pipelines, while applications still must enforce authorization rules and produce meaningful audit events. Beginners sometimes assume that using a cloud platform automatically makes security easier, but it can also amplify gaps if platform baselines are weak or unclear. Defining platform scope clearly is one of the best ways to keep cloud security from turning into a patchwork of different team habits. When scope is clear, teams move faster because they know what is provided and what is expected. Types of security architecture help you choose the right level of abstraction for the decision you are making, because not every decision should be made at the same level. Conceptual architecture describes the big ideas, such as what trust boundaries exist, what primary security objectives are, and how major components relate without specifying exact technical details. Logical architecture describes how functions are structured, such as identity services, authorization points, key management, monitoring, and data storage, and how those functions interact across zones. Physical architecture describes how the logical design maps to real infrastructure, such as where services run, how networks are segmented, and where controls are enforced in actual deployment. Beginners often struggle because they mix these levels, debating physical placement when the real disagreement is conceptual, or choosing a physical detail before logical responsibilities are clear. When you separate types, conversations become clearer because you can say we are deciding the conceptual boundary first, then the logical enforcement points, then the physical deployment. This also improves traceability, because reviewers can see how a high-level principle flowed into a concrete design choice without skipping steps. In exam scenarios, recognizing the needed level of abstraction often points you toward the best answer. Security architecture also has different viewpoints that can be thought of as perspectives on the same system, such as data-centric, identity-centric, network-centric, and application-centric views. A data-centric view asks where sensitive data is, where it moves, and how it is protected at rest, in transit, and during processing. An identity-centric view asks who or what is acting, how identities are verified, how privileges are granted, and how accountability is maintained for both people and services. A network-centric view asks how communication is controlled across trust boundaries, how segmentation limits blast radius, and how exposure to untrusted networks is reduced. An application-centric view asks how the system enforces authorization, validates inputs, handles sessions, and prevents common abuse patterns. These viewpoints are all valid, but they are not interchangeable, and using the wrong one can lead to blind spots. Beginners sometimes default to the network view because it is easy to visualize, but many modern risks live in identity and application layers where network controls alone are not sufficient. When you can switch viewpoints intentionally, you can define scope more accurately and select architectural types that match the real risk landscape. Cloud environments change how scope and types are applied because the boundary between what you own and what you rely on becomes more explicit and more dynamic. In cloud, many controls exist as services you consume rather than hardware you configure, and that shifts the architectural focus toward integration, policy definition, and evidence. Cloud also encourages automation and rapid change, which means architecture must account for drift, versioning, and consistent guardrails that keep up with delivery. A key mental model is that cloud does not remove responsibility, it redistributes it, and the architecture must reflect who is responsible for which layer. This is where service models like infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS, matter conceptually, because as you move upward, you manage fewer underlying components but still remain accountable for outcomes like access control and data protection. Beginners sometimes think higher-level services mean fewer security concerns, but the concerns often shift toward identity, configuration, and data governance. Defining scope in cloud therefore requires naming which parts are controlled by the provider, which parts are controlled by your platform team, and which parts are controlled by application teams. Shared responsibility is the heart of cloud scope definition, but it becomes useful only when it is translated into specific architectural responsibilities. The provider might be responsible for the physical data center and certain foundational services, but your organization is still responsible for how identities are managed, how data is handled, and how access is authorized. Your platform team might provide baseline network segmentation and logging collection, but application teams must still emit meaningful events and enforce business-specific authorization. If these responsibilities are not stated clearly, security gaps appear in the seams, because each party assumes another party is covering a control. Architecture is the place where those seams are addressed, because architects define the boundary contracts, meaning the expectations for what the platform provides and what consumers must do. This also affects auditability, because auditors will ask where a control is enforced and who can prove it, and shared responsibility answers must be backed by evidence. Beginners often underestimate how much cloud security depends on clear responsibility definitions rather than clever technical tricks. A well-defined scope makes cloud security manageable because it turns shared responsibility into a clear set of owned obligations. Defining scope also includes defining the time horizon of architecture decisions, because architecture is not only about today's deployment, but about the system's lifecycle. A scope statement should consider how systems will be on board, how changes will be reviewed, how exceptions will be handled, and how components will be retired or replaced. In cloud, lifecycle changes can happen faster, which increases the importance of repeatable patterns and automated checks, even though we are not discussing specific tools. If architecture decisions do not include lifecycle thinking, systems can start compliant and drift out of compliance quietly as teams move fast. A good scope definition, therefore, includes operational touchpoints, such as who reviews baseline changes, who owns monitoring requirements, and how evidence is retained as systems evolve. This is not the same as doing operations work, but it is designing the system so operations can be performed consistently. Beginners sometimes treat architecture as a design time activity, but high-quality architecture anticipates change because change is guaranteed. When lifecycle is part of scope, your architecture becomes durable rather than fragile. A common confusion for new learners is the difference between security architecture and security engineering, and clearing that up helps prevent scope creep and misunderstandings. Security engineering is often focused on building or integrating specific security capabilities, such as implementing authentication flows, creating logging pipelines, or configuring access controls in a particular environment. Security architecture sets the constraints and patterns that engineering follows, ensuring those capabilities align with risk, compliance, and enterprise consistency. Architecture should guide engineering by defining what must be true, where controls must be enforced, and what evidence must exist, while engineering decides how to implement within those constraints. When architecture tries to do engineering, it often becomes too detailed and slows down. And when engineering proceeds without architectural constraints, it often produces inconsistent and hard-to-audit results. The healthiest approach is that architecture defines the guardrails and the intended outcomes, and engineering builds the mechanisms that meet those outcomes. In exam questions, wrong answers often sound like detailed implementation steps when the question is really asking for architectural direction. Recognizing the boundary helps you choose answers that fit the architect's role. Another beginner trap is thinking that a single architecture document can define scope and types for every purpose. But architecture is a set of artifacts that serve different audiences and decisions. Leadership and governance stakeholders often need conceptual clarity and scope boundaries so they can understand risk decisions and accountability. Engineers and platform teams often need logical clarity so they can implement consistent patterns and integrate services correctly. Auditors and incident responders often need traceability, meaning the ability to follow from requirement to control to evidence through coherent records. Cloud adds the need for clear boundary definitions across provider responsibilities, platform responsibilities, and workload responsibilities, because without those, audits become confused and remediation becomes slow. A mature approach is to keep artifacts aligned so they tell one consistent story at different levels of detail rather than separate stories that conflict. Beginners sometimes assume documentation is separate from architecture, but documentation is how architecture communicates and remains stable over time. The right types of architecture artifacts make scope real because they clarify decisions and ownership in a form that can be reviewed and reused. When artifacts are coherent, the organization moves faster because fewer decisions need to be rediscovered. To make scope and types practical in your mind, it helps to imagine a simple scenario where an organization is moving a customer-facing application into the cloud. The enterprise scope might define how customer identities are managed, what data categories exist, what logging must be retained, and what baseline segmentation patterns apply. The platform scope might define how workloads are on board, how network boundaries are structured, how central monitoring is connected, and what default configurations are required. The solution scope might define the application's trust boundaries, how authorization is enforced for business actions, and how sensitive data is minimized and protected within the application workflow. Conceptual architecture might explain the major zones and trust assumptions. Logical architecture might define enforcement points and event flows, and physical architecture might map those decisions into concrete deployment boundaries. This kind of layered thinking keeps the project from collapsing into either vague principles with no enforcement or detailed steps with no coherence. It also preserves accountability because each scope has clear owners and each type has a clear purpose. When you can reason this way, you are practicing exactly the kind of architectural clarity the certification expects. To close, defining security architecture scope and types for enterprise and cloud is about making security decision-making orderly, repeatable, and aligned with responsibility boundaries. Scope clarifies whether you are shaping enterprise-wide patterns, platform guardrails, or system-specific designs, and it protects you from trying to solve every problem at every layer at once. Types clarify whether you are working at a conceptual, logical, or physical level, and they help you choose the right kind of artifact and conversation for the decision you need to make. Viewpoints like data, identity, network, and application perspectives ensure you do not miss critical risks by staring at only one layer of the system. Cloud environments make this skill even more important because shared responsibility and rapid change demand explicit boundaries, lifecycle thinking, and clear ownership of obligations and evidence. When you can explain scope and types clearly, you build architectures that are easier to implement, easier to audit, and more resilient to change, which is exactly what a security architect is expected to deliver.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.